So, as you've all heard, my name is Peter Kingera, and I will be taking you through architecture. And the topic today will be architecting for scale. So this mostly deals in building resilient digital systems. Mostly we are focusing the same, tailored towards Africa and Africa as a whole in the future. And I'd like to welcome you all to the talk. So, as we all know, we are here to talk about the invisible force behind our digital revolution, which is system architecture. Yeah, we'll explore how to build systems that are not just globally modern, but are uniquely resilient to the challenges and opportunities we face right here in Africa. That's where our theme, or our core maybe value comes from, tech tailored for Africa. So, to start with, we'll dive into the introduction bit where we have to do this talk. Yeah, so as we know, we are slowly transforming ourselves into the Silicon Savannah, and Kenya being a beacon of the innovation, mostly by the major platforms or services that keep us on the lookout of the whole world. Mostly, we can base that on M-Pesa, Safaricom's financial institution. Yeah, and Africa isn't just adopting technology, we are creating it. But what separates us is a flash in the pan idea from a lasting solution or institution like M-Pesa. It's the underlying architecture. It's the difference between an app that works in a demo and a system that serves millions reliably, even when maybe we have issues like power flickers or network slows down. So today we'll talk about the core challenge building for our reality, maybe as Africa. Going to the next part will be maybe an illustration of the same. Yeah, what is system architecture actually? So it's a blueprint of the digital systems. Definition being so the definition being the conceptual model that defines the structure, behavior, and the views of a system. It's the master plan for your software and hardware. So basically, that is built in four key layers, which are the presentation layer, there's the application layer, the data layer, and the infrastructure layer. So going deeper into the four bits, it spans all layers from what the user sees and touches all the way down to the physical servers. An example is the M-Pesa transactions, is a perfect way to illustrate the same of how the four layers work in harmony under immense load. As the visualization there shows, so the presentation layer handles the user interface, which are the mobile apps, that's the M-Pesa app. You have the USSD, web-based application, and the chatbots. Then the application layer, which is maybe interpreted to be as the brain, handles the business logic, microservices, and the APIs. We have we have the data layer. Is like the memory, the databases where data is stored, SQL. Examples might be maybe SQL and non-SQL. Caches and storage. For the infrastructure layer, this is the foundation. We have the servers, cloud networks, and the physical data centers, maybe based locally or outside. So the next bit will be handling Africa's infrastructure reality. So yeah, going on, system design in Africa must assume partial connectivity and aim for graceful degradation. So our architecture cannot be copied and passed from Silicon Valley. We have a we have a unique set of constraints where we design for users who might be on a 2G network, maybe mostly, let's assume a rural area, for businesses that experience daily power fluctuations. Maybe you're all familiar with how our situation is always like. Maybe we don't have power backups. Maybe we have a cut from the maybe fiber cut or internet is down from our major suppliers or service providers. So yeah, those are basically major problems that we face in terms of the same. So if we are planning to develop or actually create systems, we should put such factors into consideration. So yeah, and for consumers who carefully manage their data bundles, so yeah, this isn't about making excuses. It's about now actually designing with empathy and the intelligence for our market. That's we have to understand how our market is as much as we want to make it better. I believe it's we start with where we are at and try to actually make it better. So considering whatever constraints our customers or clients have and whatever challenges we might be facing. So creating solutions based on that and we actually work towards something better from there might be a better solution and something better for us to handle. So designing our context, not a textbook. We have various issues. Those are connectivity gaps, as I already explained. The urban-rural digital divide is real. Yeah, and the systems must handle intermittent and low bandwidth scenarios where maybe there is no that reach or certain places where we don't have that much reach or strong maybe internet connections. Yeah, unstable power grids. Yeah, that's what I've already said. Then architecture must include redundancy and graceful failure. We must maybe try and accommodate that high data costs. Maybe for growing businesses, we might also try to consider that. Mobile first culture, provide 5% of internet access is via mobile. So designs for small screen and touch interfaces and USSD might be yeah, available. An example being maybe you're developing a system that will try and cover a gap between a supplier who is the farmer from maybe a rural area and they actually don't know maybe how to use a mobile phone and they need to actually upload the harvest to your system as the consumer or as the seller or a broker in between there. You will have to maybe this is a real example from a client where she actually wanted me to integrate USSD integrations from Safaricom or some other service provider for her farmers to be able to, you know, yeah, for her farmers to be able to upload harvests and be able to, yeah, for farmers to be able to upload harvest and be able to actually push their harvest and give dates for the same so that they can be able to plan ahead for maybe a better business model for the same. So I guess the point is home. So going next, I'll be covering the principles of system architecture. Yeah, for our topic, which is Africa, Kenya and Africa at large. So these principles are our compass, which is resilience over perfection. Means it's better for a feature to be temporarily unavailable than for a whole app to crash. So we're trying to cover the bits we can right now with the existing problems. Then from there we can build onwards. Online first is a mindset. Your app should remain, useful even when offline. We'll be trying to cover up for the cuts or power outages and costs. Cost aware scaling is crucial. A solution that is not just raw computer power. Then API driven integrations and security by design, meaning you have to be proactively or always you have to always guard for local threats. Like, yeah, so choosing the right pattern. We are trying for the job. Have a description there for major patterns. We have the monolith to microservices, where we start with a single app, then break it down into independent services, allowing it allows you to scale critical services like payments independently without rewriting the whole system. Yeah, the next one will be event-driven architecture, which serves which services communicate asynchronously via events. So perfect for M-Pesa callbacks, maybe SMS notifications, handles delays, and retries seamlessly. Then the next one we go to serverless, run code, which maybe we run code without managing servers. Examples are AWS Lambda and Azure Functions, which reduces DevOps overhead and costs. Pay only for the execution time. Great for startups. The next one we'll cover is edge computing, which we process data closer to where it's generated. And it's ideal for IoT, maybe in agriculture, which reduces latency and bandwidth use from local sites to the cloud. Yeah. So these are the tools in our toolbox. You don't have to start with microservices. A well-structured monolith is fine for maybe an MVP, but as you grow, these patterns, give you flexibility, or the flexibility that you're looking for. You need for event-driven architecture, for instance, maybe it's a lifesaver when you're integrating with the telco API that can be slow and reliable, and maybe for serverless can dramatically lower the barrier to entry for innovation. Yeah, something kind. Then going to the next part, we have we're covering the cloud in the African context. So yeah, is we are trying to navigate the cloud and local architecture, explaining how they work. And yeah, the cloud is a powerful ally, but it's not a one size fits for maybe all our solutions. The latency of, let's say, an example of South Africa is, better or low than that compared to Europe, but it's still not zero. Then this is where local data centers and hybrid cloud strategies become a competitive advantage. Maybe it allows you to be globally connected while being locally responsive and compliant with the services or architectures you're trying to apply and implement. So diving in, we have examples of the global players who are Azure, AWS, GCP, Huawei Cloud, who have the infrastructure in South Africa, freeing and reducing latency. Have the rise of local data centers, facilities in Nairobi, Johannesburg, Lagos, that are crucial for data sovereignty and lower latency. So key challenges we have, these are compliance, major issues or major challenges that this person will cover is compliance. So some of the things that maybe hinder us from the same might be an example of the Kenya Data Protection Act of 2019, which requires citizen data to be handled with care and often stored locally. Second one will be cloud, will be the cost. Sorry, yeah, cloud bills can spiral without careful management. So maybe you find it, the bills are tend to be higher, spike from time to time. Then you have the reliability. You have internet links to cloud regions can be a single point of failure. The winning strategy is hybrid cloud. So use of cloud for scalability and global services to keep sensitive data and latency critical components on premise or in a local data center. An example there is Kenyan Bank, where you get to run customer facing mobile apps in Azure, but keeps it core transactions or transactional databases on premise for security, compliance, and latency. So yeah, that's how we get to play that in our own scenario and see how the challenges affect the same. The next bits to be covering the security and compliance. So security is not a feature you add later. It's a must to be baked maybe into the architecture from the day you start building the same. And in our context, threats maybe like the simple SIM swap fraud. Yeah, really devastating maybe when your system is attacked or your build systems are brought down. So this means building systems that don't rely solely on SMS and something like two-factor authentication. It means understanding and designing for the Kenya Data Protection Act, ensuring that how we handle our users' data is not just technically sound, but also legally compliant by such protection acts. So, building trust through secure design, the the threat landscape in Kenya, we have the themes of fraud, we have phishing scams, insecure APIs, and insider threats. So local compliance is non-negotiable. Sorry. So the Kenya Data Protection Act 2019 governs how we collect, store, and process personal data. Maybe most of us, or maybe most of people who work in companies knows this is actually taught as it's a training. We have to always protect whatever data we're processing, whatever data we're handling from clients, from customers. So yeah, we must be bound, and it's also maybe a regulation served by the ISO for those companies that are compliant. So we're also trying to build the same. If we build, we have to make sure that whatever data we handle from clients, customers, our own employees' data has to be protected and not actually leaked. Central Bank of Kenya guidelines mandates strict cybersecurity for financial services. It's a big premise, so it has to handle that. GDPR ensure for any product with users in the EU. Architectural best practices. We have examples of encrypt everything, data at rest, and in transit. Secure API gateways use which includes maybe using tokens, rate limiting, and API keys. The other one is identity and access management, principle of least privilege. Then we have continuous monitoring and patching using of tools like an example of Prometheus and Grafana. So for security and compliance, we have to make sure that we follow them so that whatever systems we're building, as much as we're trying to offer the simplest and the easiest of systems for clients and features, we have to make sure that the security is paramount, and yeah, they're always protected. So yeah, we ought to be integrating that with the same. Then for maybe a case scenario, moving forward to a case scenario or a case study, we are trying to mostly expand on the our biggest giant or a system that serves us maybe I'll say almost seamlessly. You don't have troubles, never have downtime. It's the biggest system offers. I've never heard of a moment maybe years ago, but nowadays you can't hear that. I have issues with my M-Pesa, can't send money, maybe from a supermarket where you have to do couple of transactions towards one customer, something. Yeah. But yeah, we are trying to analyze or have a M-Pesa scalable architecture and see how we manage to hold up till now. So we're trying to deconstruct till it's a continental giant, how M-Pesa handles scale and resilience to be able to offer services, or they've been offering the services since, yeah, it's been long, and they managed to be doing that. So they have the microservices architecture, the wallet service, it's the transaction engine and notification service, which are decoupled. This allows them to scale independently during peak times, maybe end month or times where, yeah, the data is a lot more to handle. Then we have API first design, which is clean APIs allows seamless integration with banks, merchants, and other telcos, creating an entire ecosystem. So yeah, everyone is aware of the Daraja API, which is used for the same. So it's easier for developers to integrate maybe in their own systems, maybe big banks. They have multiple or many clients who rely on the same. The next one you have the load balancing and redundancy, how the same is handled. Traffic is distributed across multiple data centers to handle millions of concurrent requests and ensure uptime. So concurrent requests, those are all the services maybe they offer. We assume maybe in a second how many people actually send money via PayBill, there's till numbers. It's a big ecosystem they offer. So yeah, load balancing and redundancy help with the same. You have the offline redundancy where the systems are designed to handle temporary failures in partner systems. Maybe an example of banks API being down. So that's why I was saying we've been explaining or I've been trying to explain the offline feature where creating a system that understands your users or your current situation. Maybe you have power surge, you have internet will be down at some point. Maybe your service provider has not been able to, or they have a cut someplace. So they ought to be, you ought to be designing a system where your client can actually use it in an offline state. Yeah, something kind. Proactive fraud detection, machine learning models analyze transaction patterns in real time to flag suspicious activities. So yeah, that's actively monitoring their maybe endpoints to make sure that no malicious or people with any malicious intent will attack the system. So that enhances the security bit. And yeah, the success in Africa's digital economy depends on an architecture that scales locally, not just globally. That's why I'm trying to insist on as much as we build that system, we have to make sure that it serves all the needs that are there currently as much as we want to grow. So, looking at that masterclass in the African architecture, yeah, it's the M-Pesa. It's not just that it's not monolith, it's the collection of those specialized services. And that's why when there is a promotion, maybe a promotion and airtime purchases spike, it doesn't necessarily affect person to person transfers. The use of load balancing and redundancy is why the service stays up. If maybe one data center has an issue, this level of architectural thinking powers a national utility. So thinking of maybe systems that are building, maybe mirroring the same and being able to consider such factors will be moving somewhere forward. Going to the next bit, it's building for the future. And we are looking at the emerging technologies. Let's say the next wave, architecting for tomorrow. We have an example, or we have the AI and data engineering, which is here with us, which is detecting data pipelines for predictive agriculture, alternative credit scoring, and smart city management. Next one is IoT, which is Internet of Things, designing systems to handle data for millions, sensoring, for sensoring, smart metering, logistics tracking, and climate smart agriculture. The next one is blockchain. Yeah, it's also an emerging technology which explores architectures for secure digital identity. The other one will be 5G and edge computing, the future of low latency applications, maybe in healthcare, education, and entertainment, which will rely on architectures that push computation to the network edge. So for architectural realizations, they will determine what's possible tomorrow. The data we collect now from maybe IoT sensors in farms needs a pipeline to feed AI models. So everything else is getting interconnected. The need to, or the need for unforgeable digital identity calls maybe for blockchain-based architectures. As 5G rolls out, we must be ready to design for edge computing. We are not just building for today's, we are also building a digital backbone for Africa's future. Next bit, as we wind up, we're going to look at tools and frameworks for African architects. I get to look at examples of tools we get to use, maybe for cloud providers. We have an example of AWS, Google Cloud, Microsoft Azure, and Huawei Cloud. API management, we have the example of Postman, Swagger. Most of these, maybe we have interacted with them. For databases, there is Postgres, SQL, we have MongoDB. There's also an example of SQL, MySQL, messaging in queues, Apache Kafka, Celery, monitoring and observability. We have Prometheus, Grafana, and Datadog. Infrastructure as code. We have Terraform, Ansible, and Pulumi. CI and CD. We have Git Actions, GitLab, CI, and Jenkins. Those are for controlled versions. Yeah. So there are some of the industry standard tools that are just as relevant and powerful in our context. Maybe we take an example of Terraform, which allows you to define your entire infrastructure, servers, network, databases as code. This is a game changer for reproducibility and disaster recovery. The key is to choose the right tool for your specific problem and team capacity. Then going to our last bit, then maybe takeaways or lessons we have gotten from the same. We can say we have to design for uncertainty. Yeah, we have to design for uncertainty, assume network power or even political disruptions will happen. Building buffers and fallbacks will come in handy. So yeah, we have such situations where we have blackouts now and then, we have them under manuals, and maybe you have to build for such situations. Simplify simplify the user experience. Many of our users are first time digital adopters. Complexity is the enemy, for adoption. As much as we create systems, creating that system that's a minute farmer will use them there for their crop produce or their animals to record such things. We have to simplify for them so that they can feel, accommodated and they can able to adapt to the growing technology as fast. Yeah, then the third one we observe and iterate in the field. A week of field testing with real users in rural areas is more valuable than a month of perfect simulations in Nairobi. Okay, means as much as you're building for a client, you have to be there with them physically on the ground, kwa ground, ukienda kuangalia, how much or how the situation they have and how they're handling it. The other one is collaborates regionally. The future is interconnected. Build architectures that can easily talk to systems maybe in Uganda, Tanzania, Rwanda, and beyond. An example of what we'll be talking the continental giants, Safaricom and Pesa, yeah, such a system. So beyond the technical specs, yeah, here is the lived wisdom. We must be humble enough to know that our users, the reality is different from our own. Whatever we visualize in our minds as we develop or as we architect what you're doing, you have to put in consideration our actual clients and be humble to actually go down and listen to what they have. We must get out of offices and test our systems where they will actually be used. Maybe hospital setup, yeah. And we must think regionally. The most transformative systems will be those that connect us maybe as a country, Kenya, East Africa, into a single digital market and Africa at large. So, as of that, I will say that's maybe the end of my presentation. Yeah, and thank you all for your time. I hope those were or have been great insights and inspiring ones. Yeah, next one I'll take back to